students, today I will discuss the new chapter Thermodynamics. First, to study thermodynamics, we are interested about macroscopic system, not microscopic system. So we are interested about macroscopic system. Where the number of molecules are, huge number of molecules are involved, but in microscopic system only few molecules are involved. That's why in thermodynamics we are interested about macroscopic systems. Several changes of energy may occur during burning of coal, fuel, etc. And in chemical reactions, there also occurs change of energy. So, in thermodynamics, we are interested about the initial condition of the system and the final condition of the system. So, what is thermodynamic system? Suppose you have taken a small portion of universe which is under experiment. This is called system. And rest of the universe is called surroundings. That means universe equals to system plus surroundings. Now, what are the types of systems? There are three types of systems. One is open system. Suppose in a beaker you have taken some hot water. There, exchange of matter and exchange of energy both can be happen. So that type of system is called open system. Second type of system is closed system. Suppose we have taken a sealed container made of some conductor of heat, material made of which is conductor of heat, and you have taken some hot liquid here. So after some time you will see and you will observe that the hot liquid becomes cold. That means your exchange of energy occurs. But as the container is sealed, there will be no exchange of matter. So that type of system is called closed system. And what is isolated system? We have taken a sealed container. Again, this container is made of some non-conductive of heat, non-conductor of heat. Then you see, if you taking some hot liquid here, after some time there will be no exchange of energy and no exchange of matter as well, as the material of the container is non-conductor of heat, so no passage of energy, no exchange of energy, and matter is occurring here. So you can take an example of isolated system. If we keep hot water or hot tea or hot milk in thermoflask, that will be approximately an example of isolated system. This is called isolated system, where no exchange of matter and no exchange of energy occurs. Now we will discuss extensive property. And intensive property. So what are extensive properties? The properties which are mass dependent. The mass dependent properties are called extensive property, and mass independent properties are called intensive properties. The example of extensive property is entropy, volume, mass, enthalpy, etc. And the examples of intensive property: molar entropy. Entropy is extensive property, but molar entropy is intensive property, as the mass is fixed at density, pressure, molar enthalpy, molar free energy. These are etc. These are intensive properties. Now we are discussing what are thermodynamic variables. So pressure, volume, temperature, and composition of the system. These four are called thermodynamic variables, as because of the state of the system is dependent on these properties. So these are thermodynamic properties or thermodynamic variables. Now I will discuss what is thermodynamic state. When a system in equilibrium, there may be three types of equilibrium. One is thermal equilibrium, number two is mechanical equilibrium, and number three is chemical equilibrium. In thermal equilibrium, when time passes, the temperature of the system remains constant. That is called the system is in thermal equilibrium. And when system under investigation remains in such a state that there will no unequal force, then we call the system in mechanical equilibrium. And in chemical equilibrium, when time passes, the composition of the system remains same. Then we call the system is in chemical equilibrium. Now I will discuss what is the state function of a thermodynamic system. The properties, suppose the pressure of the system, volume, temperature, entropy, enthalpy, free energy, these variables does not depend on the path on which the change occurs, but depends on the initial, only dependent on the initial and final state of the system. So these are called state functions of a thermodynamic system. But work and heat are not state functions because they are dependent on the path through which the change occurs. So work and heat are not state functions, but these properties, pressure, volume, temperature, entropy, enthalpy, free energy, these are independent of the path, so they are called state function of the system, but work and heat are not state function of the system. Thank you all viewers for viewing my channel and attending my chemistry class. Today is the first class of thermodynamics. We will discuss in the next classes the remaining portion of the thermodynamics. Thank you.